We will learn about Azure resources and subscriptions in this webinar. So what exactly is an Azure resource? An entity that is maintained by Azure is referred to as a resource. Examples of Azure resources include virtual machines, virtual networks, and storage accounts. There must be a resource group for each resource in Azure. A resource group is a logical container that connects several resources so you may manage them as one unit based on security and lifetime. For example, if the resources in question have a similar lifespan, such as those in an N-tire application, you can create or delete them as a group. In other words, a resource group contains all of the items that you jointly produce, manage, and deprecate. What exactly is an Azure subscription? An Azure subscription is similar to a resource group in that it serves a logical container for resource groups and their associated resources. Azure subscriptions are also linked to Azure Resource Manager controls. This brings us to Microsoft Azure Resource Manager. It is a service that houses the RESTful APIs used by clients, including Azure PowerShell, the Azure Portal, and the Azure CLI to manage resources. Although these clients use the REST API to connect to Resource Manager does not have the ability to manage resources directly. Instead, each type of resource in Azure has its own resource provider. Azure Resource Manager establishes a connection with the resource provider for that resource type to fulfill a client request to manage a specific resource. For instance, Azure Resource Manager connects to the Microsoft Compute Resource Provider when a client requests to manage a virtual machine resource. In order to manage the virtual machine resource with Azure Resource Manager, the client must provide an identifier for both the subscription and the resource group. You can learn how to link an Azure subscription with the Azure Resource Manager controls if you have a basic understanding of how Azure Resource Manager operates. We will go over a series of controls before Azure Resource Manager may carry out any resource management requests. The first control is that a validated user must make a request. Additionally, in order to enable user identification capability, Azure Resource Manager has to be in a trusted relationship with Azure Activity Directory, Azure AD. Users can be divided up into tenants in Azure AD. Typically connected to an organization, a tenant is a logical construct that donates a secure, dedicated instance of Azure AD. Each subscription can be linked to a tenant in Azure AD. Users must have accounts in appropriate Azure AD tenant in order to control resources in a specific subscription using a client request. The user's level of authorization to submit the request is verified in the following control. Users are given permissions using Azure Role-Based Access Control, Azure RBAC. A user can only access a certain resource with the permission listed in an Azure role. These permissions are put into effect when the user is given the role. For instance, the built-in owner role enables a user to perform any action on a resource. The next check is to see if the request is permitted by the Azure Resource Policy settings. The permitted operations for a given resource are specified by Azure Resource Policies. For instance, an Azure Resource Policy may stipulate that only a particular kind of virtual machine deployment is permitted by users. The following control verifies that request doesn't go above an Azure subscription limit. There is a cap of 980 resource groups per subscription, for instance. When the limit has been reached and you are asked to deploy another resource group, decline the request. The last check is to ensure that the request is within the budget you have set for the subscription. For instance, if the request is to deploy a virtual machine, Azure Resource Manager confirms the subscription has appropriate payment details. We'll study Azure tags during this session. Your Azure resources, resource groups, subscriptions, and management groups hierarchy are organized using tags. A name and a value pair make up each tag. There should be some compliance with tagging if you were working at the project level to secure the hierarchy of your Azure resources, resource groups, subscriptions, and management groups, or for better filtering, monitoring, or querying a few situations. Let's look at all the tags that should be included when creating an Azure resource and an example of its use. The topic of Azure storage accounts will be covered in this session. All of your Azure storage data objects, including blobs, file shares, queues, tables, and disks, are stored in an Azure storage account. The storage account provides a unique namespace for your Azure storage data that's available from anywhere in the globe over HTTP or HTTPS. The storage account's data is enduring and highly available, safe, and incredibly scalable. Multiple storage account options are available with Azure Storage. Each category has a unique pricing structure and supports a variety of features. Let's talk about a few of them. The first type is Standard General Purpose V2, which is a form of standard storage account for tables, queues, file shares, and blobs. It is recommended for the majority of Azure storage scenarios. It supports storage services including Azure Files, queue storage, table storage, and blob storage including data lake storage. The following is Premium Block Blobs, a premium storage account types of block blobs and append blobs. It is advised in cases requiring consistently low storage latency, high transaction rates, the use of tiny objects, or both. Storage options like blob storage are supported, including data lake storage. Following that, Premium File Shares, a premium storage account type that is just for file shares. It is recommended for large-scale enterprise or high-performance applications. If you want a storage account that supports both server message block (SMB) and NFS file sharing, choose this account type. Azure File Storage Services are supported. Premium Page Blobs is a premium storage account type that is only for file shares. Only page blobs are supported by this premium storage account type. Then there's Azure Blob Storage. It is a Microsoft's cloud-based object storage service. Massive amount of unstructured data, such as text or binary data, are best stored using blob storage. Some applications for blob storage include: it directly serves documents or images to a browser. For disturbed access, it stores files. Using blob storage, we are able to stream audio and video. Writing to log files is simple. It keeps the data for archiving, disaster recovery, backup, and restore. It keeps the information so that an internal or hosted by Azure service can analyze it. Azure Blob Storage is essential to overall Microsoft Azure platform since many Azure services will store and act on data that is stored in a storage account inside the blob storage. And each blob must be kept in its own container. The storage location for various blobs is more akin to a folder in the container. We can design security policies at the container level and assign those policies to the container, which will cascade to every blob contained within that container. A storage account can have an unlimited number of containers, and each container can hold an unlimited number of blobs up to the storage account's maximum size limit, up to 500 TB. Flat storage is the foundation of blob storage. Thus, it is impossible to create a container inside of a container. Consider the case where we wish to distinguish between personal and professional videos after creating container-like videos. Then for personal videos and professional videos, we can prefix the blob names with personal and professional respectively. For personal videos, the blob name will be displayed as personal video 1, personal video 2. For professional videos, it will be professional video 1, professional video 2. In this way, we can build a virtual hierarchy within the Azure Blob Storage service, but we cannot build a container inside another container. Azure provides 3 different blob service types. Blob in total, it can hold up to 4.7 TB of text binary data. It is the data block that can be handled separately. Blobs can be used primarily to decrease the upload time while uploading blob data to Azure. Whenever we upload any papers, media files, or video files, unless they are log files, we can generally use blobs. Append blobs are composed of blocks similar to those in blobs, but they are enhanced for append operations. It is perfect for applications like virtual machine data logging. For instance, you would append data to the end of an application log or event log. Therefore, we may define the blob type when uploading a blob into a container using the Azure site or code. Page blob. It can hold up to 8 TB of random access files. The VHD files that supports VMs are kept as page blobs. We often work with block blobs and append blobs. By default, page blobs are produced. The storage account is performed when we construct a virtual machine and the disks linked with the virtual machine are kept in the storage account. However, for majority of storage systems that we are familiar with, we either utilize block blobs or append blobs depending on the needs when creating applications like YouTube or monitoring software. Let's move on to the following subject, which is content delivery networks. A content delivery network (CDN) is a distributed network of servers that delivers web content to users in an efficient manner. In order to reduce latency, CDNs keeps cached material on edge servers at point of present (POP) sites that are close to end users. Azure Content Delivery Network (CDN) gives developers a worldwide option for quickly sending high bandwidth material to customers by caching their content as purposefully positioned physical nodes throughout the globe. By utilizing numerous network optimizations with CDN POPs, Azure CDN may additionally hasten dynamic stuff that cannot be cached. For instance, route optimization to avoid Border Gateway Protocol (BGP). Using Azure CDN to provide website assets have several advantages, including end users will experience better performance and better user interface, especially when utilizing apps where loading material requires numerous round trips. For example, the beginning of an event for a product launch, large scaling is better able to handle sudden high loads. Reduce the amount of bandwidth going to origin server by distributing user requests and serving content directly from edge servers. So how does it work? A user, alias, requests a file, also known as an asset, using a URL with a special domain name such as endpoint name .azureedge.net. This may be a custom domain or an endpoint hostname. The DNS directs the request to the POP that offers the best performance, which is typically the POP that is nearest to the user geographically. If none of the POP's edge servers have the file in their cache, the POP asks the origin server for it. The origin server can be any publicly available web server, an Azure web app, an Azure cloud service, an Azure storage account, etc. An edge server in the POP receives the file back from the origin server. The file is cached by an edge server in the POP, which then sends it back to the requester, alias. Until the time to live TTL indicated by its HTTP header expires, the file is still cached on the edge server in the POP. The default TTL is 7 days if the origin server didn't specify a different one. The same file can then be requested by further users using the same URL that alias used, as well as by directing them to the same POP. The POP edge server returns the file immediately from the cache if the file's TTL hasn't run out. A quicker, more responsive user experience is the result of this approach. There are certain prerequisites for using Azure CDN, like as at least one Azure subscription must be used. The CDN profile, which is a list of CDN endpoints, must also be developed. Every CDN endpoint has a unique configuration that users can alter to accommodate the desired access and content delivery behavior. You can use several profiles to categorize your CDN endpoints according to online applications, internet domains, or other factors. If you want to use a variety of pricing tiers, you must construct various CDN profiles since Azure CDN pricing is applied at the CDN profile level. For several resources, each Azure subscription has preset limitations, including the maximum quantity of CDN profiles that can be produced, the maximum number of endpoints a CDN profile can support, the number of unique domains that can be mapped to a given endpoint. We will study Azure File Storage and Azure File Sync in this session. The main usage of Azure File Storage is to create a shared drive between two servers or users. The first requirement for the Azure File Storage structure is an Azure Storage account. The Azure Storage account's offerings include Azure File Storage. After we have created an Azure Storage account, we will set up file sharing. Within a storage account, we can construct an infinite number of file shares. Once file sharing has been established, it is possible to construct directories which function similarly to folders and upload files into them. Once a file share has been established, it can be mounted on any virtual machine, whether it is located inside or outside of Azure. Several lots of aspects Azure File Storage include storage account. A storage account is required for all access to the Azure storage service. When using Azure File Storage, blob storage, tables, and queues, we must keep in mind scalability and performance goals. All of them may be sharing the same performance goals under the storage account, in which case all the services will be subjected to the same storage account restrictions. Directory. It is a hierarchical structure that is optional. File. A shareable file. A file's maximum size is 1 TB. Share. A file storage share is an SMB file share in Azure. We cannot construct a directory in a storage account. Instead, the directories and files must be created in a parent share. Before creating directories for uploading, we must first construct a file storage share. An account may have an unlimited number of shares, and each share has a total storage capacity of 5 TB that may accommodate an endless amount of files. However, we can construct another file share if we require more space than the available capacity. URL format. For a file REST protocol request performed to an Azure file share, you can retrieve your data using one of two built-in, handy methods provided by Azure Files, either independently or together. Direct cloud access comes first. Any Azure file share can be mounted on Windows, Mac OS, or Linux using the File REST API or the widely used server message block SMB protocol. However, if we employ the SMB protocol, we have two considerations to make. First, the SMB client in the OS must support at least SMB 2.1 if we are mounting the file share on a VM in Azure. Second, the SMB client supported by the workstation must be at least SMB 3.0 with encryption enabled if we wish to mount a file share on an on-premises device like a user's workstation. Additionally, the SMB client must at least version 3.0 if we are mounting an Azure file share inside of our on-premises data center, but if we are establishing a virtual machine in Azure, it can be version 2.1. The second option is Azure File Sync, which enables the replicant of shares to on-premises or Azure Windows servers. Through the Windows server, our users can access the file share such as the SMB or NFS share. Any frequently accessed files will remain synced to the server endpoint, and any less often accessed material will be transferred to the Azure file share. By doing so, we can increase the speed at which data is delivered to customers while also conserving storage. We shall now discuss Azure File Sync. It makes it possible to centralize your company's file shares on Azure files while retaining the adaptability, speed, and compatibility of a Windows file server. Even though some customers might want to preserve a complete copy of their data locally, Azure File Sync also offers the compatibility of turning Windows Server into a rapid cache of your Azure file share. To access your data locally, you can use any Windows Server compatible protocol, including SMB, NFS, and FTPS. There is no limit to the number of caches you can have worldwide. Azure File Sync offers a number of advantages as the first is cloud tiering. Your most frequently viewed files are cached on your local server, which cloud tiering is enabled, and your least frequently accessed files are tied to the cloud. The amount of local disk space needed for caching is under your control. Tired files may be promptly retrieved when needed, resulting in a seamless experience and cost savings because you only need to store a small portion of your data on premises. The next advantage is multi-site access and sync, which works well in distributed access settings with Azure File Sync. As a part of your Azure File Sync deployment, you can set up a local Windows server for each of your offices. Any modification made to a server in one office instantly update all other offices' servers. Following that are business continuity and disaster recovery. Azure File Sync is supported by Azure Files, which provides numerous redundancy choices for highly available storage. Your local server is reduced to a disposable caching device because Azure has robust copies of your data, and you may recover from a failing server by adding a new server to your Azure File Sync deployment. You provision a different Windows server, install the Azure File Sync agent on it, and then include it in your Azure File Sync deployment rather than restoring it from a local backup. In order to get your server up and running as quickly as possible, Azure File Sync downloads your file namespace before downloading any actual data. You can utilize Azure File Sync with Windows clustering or include a warm standby server in your deployment for even quicker recovery. The final advantage is cloud-side backup. By using Azure Backup to take centralized backups in the cloud, you can pay less on-premises backups. In order to schedule your backups and manage their retention, you can use Azure Backup to automate the process. Azure Files SMB shares include native snapshot capabilities. Additionally, Azure Backup connects with your on-site servers so that any changes you make when you restore to the cloud are automatically downloaded to your Windows servers. Let's look at how to set up and manage resource groups. Log in into the Azure portal first. Select resource groups next. Next, choose Add. Fill in your selected values. Subscription. Choose a subscription for Azure. Resource group. Enter the name of a new resource group. Region. Pick a place in your Azure like Central US. Next, choose Review plus Create. Select Create Next. A resource group can be created in a few seconds. The newly formed resource group can then be opened by selecting it after selecting Refresh from the top menu to update the list of resource groups. Or to access the recently formed resource group, click Notification, the bell icon from the top, and then pick Go to Resource Group. We'll go through the given steps to transfer resources from one group to another. In the portal, click the resource. Choose Move. The management choices for a storage account are displayed in the screenshot. Depending on your requirements, either move to another resource group or move to another subscription. Tagging facilitates logical resource group and resource organization. Launch the portal's resource. Choose tags. The management choices for a storage account are displayed in the screenshot. Select Save after entering the tag settings. Follow these instructions to create an Azure storage account using the Azure portal. To get a list of your storage accounts, choose Storage Accounts from the left portal menu. Toggle the portal menu on if it isn't already if you click the menu button. Select Create on the Storage Accounts page. When you select the Review plus Create tab, Azure verifies the settings you have selected for your storage account. If the validation is successful, you can establish the storage account. The portal displays which parameters need to be changed if validation fails. Use the Azure interface and the steps below to upload a blob to your new container. Navigate to the container you created in the previous section of the Azure site. Choose the container to display a list of the blobs it holds. Since this container is new, it won't yet have any blobs inside of it. By clicking the Upload button, the Upload blade will open, allowing you to search your local file system for a file to upload as a blob. To set up additional upload options, you can opportunistically extend the Advanced section. To upload the blob, select the Upload button. This allows you to upload an unlimited number of blobs. You'll notice that the container now lists the new blobs.